take a look at how to go through this question. So I've drawn a vector diagram already, and you can analyze the question if you want on your own, but first we're going to go with the steps I've described in the previous video, and then we're going to solve this problem. So first of all, the step one is to look at the triangle that you have your angle at. So it's not like I have my angle here, so I'm not going to use this part of the triangle. But take a look. I have an angle here. And even though it's a part of a bigger triangle, I'm going to split it like this so that you can actually get a triangle from it. So let's just outline that. I'm going to be using this triangle. And remember, what we're trying to find is this long line. So first of all, we want to find the component of this part. Let's take a look at how we can utilize this to our benefit. We need to find the x and y components. We could do it here. That can work. So now since I've split this into a 90 degrees, so then that must mean this side is 48 degrees. I'll draw a new triangle for that. Okay. This will be 48 degrees, and as we know, this part is 60 degrees. Sorry, 60 ms. We want the y component and the x component, because step one is use whatever angle you have, make a triangle out of it somehow. Even if you have to do these imaginary dots, find the x and y component. Just a reminder, the x component, the y component here, if you perchance did like this, which looks confusing, but it's the y component here will be the same y component here, and the same x component here will be the same here. Anyways, we're not going to use the top because it looks confusing in this case. You can look at the top and the bottom, and you want to find which side makes sense to add a right triangle in, and it's typically the same side where they already gave you a value. Okay. Typically don't use the hypotenuse because this part looks confusing. Just use this part where it's in line with the value that they already gave you. Okay, so we can use Pythagoras. The y will be sine 48 times 60, and this will be cos 48 times 60. This is 40.15, and this is 44 times 59. Okay, so I'm just going to check something here. According to the reference coordinate that I have in mind, the north will be positive and east will be positive as well. So since everything here, the y component and the x component seems to be going east and north, so these are going to be positive. Now we got the x and y component, so that's step one. Step two is to take a look at how these components connect to a bigger picture of the triangle that we have. So we found the x component, and we have the y component. Is it looking familiar? Since we're looking for this long hypotenuse, and we just got the entire y component of the hypotenuse and the x component of a hypotenuse because we have this and this. You see where I'm coming? This is going to be 800 plus 40.15. This part is going to be, now we are going to use Pythagoras Theorem, square both of these, add them together, whatever they get, is square root it, and that will be the hypotenuse. Let's try it. So what I got was, so then, because the ground velocity is hypotenuse, and we found the hypotenuse, There we go. That's a magnitude. And of course, you will need to find the angle as well because velocity is a vector. But I'll leave that to you because it's not too hard.